Welcome back to the channel. In today's video, we will cover a very important networking concept, and that's MTU, Maximum Transmission Unit, what jumbo frames are, and finally how to configure them on a FortiGate firewall. You might have received some requirements from your customer or from your organization, like you want to change the MTU on a FortiGate interface, or you want to change the MTU on any other networking device. This might have given you some challenges, whether how to change the MTU, whether there will be any issues due to MTU changes, and whether firewall supports changing the MTU. So we will be answering all these questions in our today's topic. So let's get started. So first we need to understand what is MTU, why we need to change MTU, or why it is required or may not require. So MTU stands for Maximum Transmission Unit, which defines the largest packet size in bytes that can be transmitted on a network interface without fragmentation. Without fragmentation means, so when we have a MTU configured on any networking device, the maximum transmission unit, okay, so any packet that travels a device can have a maximum size of the MTU. By default, the MTU of any interface is configured as 1500 bytes, okay. So if the frame is higher or not higher, larger than 1500 bytes, then what is done is the frame is fragmented into smaller segments or smaller sizes. So let's say if you send a packet of 1700, for example, you send a frame or a packet for 1700 bytes to the firewall. This is a FortiGate interface or a FortiGate firewall or any other, it can be any other networking device as well. Okay. MTU on the device is configured as 1500. In this case, whenever this traffic is being sent from client PC, any device on your network, once it reaches the FortiGate and it checks the MTU of the packet, and the MTU of the packet is greater than the configured value, then this packet will be fragmented, or this frame will be fragmented. What does fragmented means? It will be divided into smaller parts. So one frame can only have a maximum size of this 1500. So this particular frame will be fragmented into two frames or two packets. One will go as 1500 and the other will go as rest of the 200 bytes. Okay. So this is the role of MTU and the fragmentation. So fragmentation is dividing a larger packet, larger frame into smaller size, because that exceeds the configured MTU of an interface. Now, whether this will be dropped, accepted, that also depends on the configuration. But if it is larger than the MTU and if the packet can be fragmented, then it will be fragmented, otherwise it will be dropped. Okay. You might be aware about DF bit in a frame or packet. If traffic is coming with a DF bit set, then the networking component or the FortiGate will not be able to fragment the packet, because the client says DF bit is set, means do not fragment is set. That means the networking device cannot fragment as the DF bit is set into the network, set into the packet. So then in that case those packets will be dropped. So that's the role of MTU on a interface of any networking device. For Ethernet networks, the default MTU is usually 1500 bytes for all of the networking components, be it Cisco, Palo Alto, or anyone. So generally all the networking components have a configured value of 1500. There are requirements, or there are various applications which requires a higher frame size or higher packet size due to the application demand, or they want to send bigger packets rather than small chunks of packets fragmented into the network. They need to send bigger packets. This is generally useful like for your backup applications, replications, where you are transferring a huge data like in TBs between the sites or between the servers. You might have some voice applications, bigger voice applications, or there can be various scenarios where you want your network to support a higher MTU, or you want your devices to allow a higher frame size so that a higher speed can be transferred. So in that case, there is a requirement, or in those scenarios there is a requirement to change the MTU of an interface if you want a higher frame size, higher transmission speed, so that the packets don't get fragment and any issues due to the fragmentation. Why it matters? If the MTU is too small, you will see unnecessary fragmentation, which increases the overhead on the device. And if it's too large and packets get dropped, it can cause connectivity issues. So correctly setting the MTU is important for network performance and stability. If all your devices supports bigger sizes, then you may choose, or better to go for a bigger MTU instead of just staying on to the default ones. That varies or depending on the requirement, as I discussed. When the demand increases or when the requirement is there based on your applications, then jumbo frames come into the picture. What is jumbo frame? Any packet or any frame, Ethernet frame, that's larger than the standard byte, that's larger than the standard 1500 byte. Typically, jumbo frames are up to 9000 bytes. So when someone says or when someone discusses about the jumbo frame, the initial understanding is like jumbo frames are the frames which has a 9000 bytes in size. But 9000 is like most of the people prefer 9000 as the jumbo frame, so that this is you can increase up to the 9000 on any interface. But the jumbo frame definition itself is the packets which are larger than the default ones are called the jumbo frames, and they can go up to 9000 bytes, even higher like 11,000 also, but as a standard the jumbo frames are near around 9000 bytes. They are mostly used in data centers, storage networks, and high performance LAN environments where large amount of data needs to be transferred efficiently. As I told you, because you might need a replication between the DB servers, or backup between the servers, between the sites. So in such scenarios, instead of doing the fragmentation of the packets, it's better to increase the MTU, increase the jumbo size, increase the frame size of the packets. What are the benefits? Reduced CPU overhead per packet, because the device don't have to do the fragmentation for every packet that is higher than 1500. There is no need of the fragmentation. Any issues due to the fragmentation will not arise, because then we are not performing the fragmentation. Improved throughput due to a higher MTU, and this is generally useful in SCSI, SAN or VM environments because they can support higher MTUs. Important note, all devices along the path must support jumbo frames. Okay, this is important. Why? Let's say you have a FGT in on the network path. Okay, and this FGT is connected to a router or switch. Same way here there is a switch connected. There is a switch. Okay, and here you have a client connected. If the client is sending the packet with 9000 jumbo frames, the switch is configured for 1500. So the switch will drop this packet. It will not even reach the FortiGate. Same way, let's say if it is configured for 9000, this device will allow the packet to FortiGate. FortiGate will allow to the upstream, but this might have a 1500 MTU. In this case, this device will drop the packet, right? So when you are enabling jumbo frames or changing the default MTU, make sure the MTU is getting changed, or you are changing it on all the device across your network path, or within your data center, within the network that you control. So you make sure you are changing it on all the upstream or downstream devices to handle this MTU properly, to handle the jumbo frames. So this is what so that's what a jumbo frame is. Packets, frames, Ethernet frames larger than 1500 bytes, and mostly the jumbo frames are not up to 9000 bytes, and we call like 9000 bytes frame as a jumbo frames whenever we are talking technically, or everyone idea or perspective is like 9000 bytes packets are called the jumbo frames. How to configure these on a FortiGate interface? What you have to do, this is available only in CLI. Only in CLI you can do, not in the GUI, only in CLI, and cannot be changed from GUI. This option is only under CLI. You have to do config system interface, edit port and the port number. It can be any port number depending on your scenario. You have to use this command set MTU override enable, and then set the MTU. Set MTU to 9000, for example, the maximum or the jumbo MTU for a frame. Next and end. So this is how you configure the MTU on a FortiGate interface. What this command does is set MTU override enable allows a custom MTU. So if you don't do MTU override enable, this change will not take effect, or this will not even give you the option for this command. You will not be able to execute this command until you enable the override. Override enable means change the default configuration of the MTU, which is 1500. If the interface is a lag interface or a bundle interface, we also call port channel interface in terms of Cisco or networking. So if it's a aggregate lag or port channel, then these MTU changes should be done on the lag interface, not on the physical interface. Verifying the MTU, whether your changes has been taken place or not, or even before the changes you want to verify what is the current MTU of the interface. So you have to do is show system interface. This will show you the configuration of the interface and if that is configured. Otherwise, the current active, like this is based on the configuration. This is based on the configuration, and this is actual. What is the current running on the interface? So you can use the command diag hardware device info NIC and the port number. This will tell you the MTU of the interface, and even fnc_ctl ifconfig, this command fnc_ctl ifconfig will also tell you the MTU of the interface. Once you have configured or made the changes, please verify like your changes has taken effect to confirm MTU is changed, override is enabled. What are the precautions that you need to take care while changing? So if the device is having a high volume of traffic, perform these changes during a maintenance window to avoid any kind of issues to your running applications or to the traffic. This will not have impact for sure, but to avoid any issues to your applications, you should take a precaution. Increasing the MTU might not have any impact, but decreasing the MTU may have impact on applications traffic, because you may not know how your application is working or how the traffic is flowing, whether your application traffic is sending some DF bit is set or not. So you may be unaware about the application architecture or how the application handles that particular traffic. So better to use in the meantime window, less traffic. But based on all my experience, mostly there are no impact during MTU changes. But to avoid, so that I don't want you to be in a bad situation which might have an impact, please verify the neighbor devices upstream and downstream for similar MTU configuration so that they matches similar MTU. These issues will not be due to the firewall interface MTU change. Instead, these might be due to how the downstream upstream devices are sending the traffic or how application handles the fragmented packet. So performing this MTU change on a FortiGate perspective is perfectly fine, no issue from the FortiGate, but the issue can be to your running traffic because of how the neighboring devices are sending or application is handling that MTU part. Not MTU, I mean the fragmentation part. If they are using any DF bit in the application, if they, for example, mostly the voice application or video kind of application, they always use DF bit sets so that the networking components cannot fragment such kind of traffic. So in such scenarios, on the FortiGate, we also have this option, ping options, where you can do a ping by using a custom size and you can test it. So execute ping can be used along with these options. Ping options, DF bit, yes, set a DF bit, like you want to test for testing purpose, you can use ping options, DF bit, yes, ping option size 8972, and then ping the destination whatever you are testing to know like what is the maximum MTU you were able to transfer. So you will be, this is something like to discover what is the MTU your neighboring device has. For example, this is one device and this is FortiGate. Okay, you will send a ping request to 1.1. Here it's 1.1. You are sending a packet with DF bit set and 8972 header. So if this device allows it or having this MTU configured here, this will be passed to the client. But if this device does not support this MTU, so this packet will be dropped. So you will be able to discover or confirm, okay, whether this MTU size or datagram size can pass through your network. So you can use these commands to test. Even from the client PC, any Windows PC, you can use the ping command to check the datagram or MTU across your network path. In the ping, I think the option is ping minus L. Yeah, I think yes. Let's start our lab time. We are on our FortiGate. Let's see. Okay. First thing I told was show system interface port 1. Nothing. It's not showing any MTU here. Why it's not showing? Because it's set to default. So what you have to do is show full system interface port 1 and you will be able to see the MTU here somewhere. Where is the MTU? There are so many options. Let me grab it quickly. Grab MTU. Okay. Set MTU override disable. So MTU override disable means there is no custom MTU. Okay. Now if you do diag hardware device info NIC port 1 diag, so you can see here the MTU is shown as 1500. So the command that you have to use is diag hardware device info and then the port number. So under this you will be able to see the MTU. Okay, this is how you can verify, or you can use fnsysctl ifconfig and port 1. So under this is like a Linux command available on the FortiGate using fnsys. So fnsys ifconfig, this is Linux command and you can see the MTU is 1500. Now if you want to change the MTU, config system interface set MTU edit port 1 set MTU override enable and set MTU and then the MTU. So you can see here maximum transmission unit, it can be from 68 bytes up to 9000 bytes. So when we say jumbo frames 9000 bytes, this means the maximum size that is supported, and this maximum MTU value can vary depending on FortiGate models. It's not specifically restricted to 9000, but it may go up to 9000, 10,000. I think 9700 something, but it varies depending on the FortiGate models. So you have to do set MTU 9000, for example, enter, next, and okay, so this MTU is set now. Now if you check FNC CTL IF config port 1, you can see the MTU is configured as 9000. If you do diag hardware device info NIC port 1, even here you should be able to see MTU as 9000. Okay, this is how you change the MTU on a firewall interface. But let's say if that's an aggregate interface, you can see under network interface I have one aggregate leg which is having port 4 and port 5 as the members. So when port 4 and 5 are the members, diag hardware device info NIC port 4, sorry, it's port 4. Under port 4 you can see MTU 1500. Now if I go under config system interface, edit aggregate leg, set MTU override enable, set MTU 9000, and if I go under, so you can see on the physical interface it's changed. So if you have aggregate interface, you have to perform the changes on the aggregate interface, not on the actual physical interface. Hope this is all clear about MTU, how to configure MTU, how to enable the override. In case of an aggregate interface, you have to perform the changes on an aggregate interface, not the physical interface, and how to verify the MTU of an interface. So now you know what is a jumbo frame, what is the maximum transmission unit, MTU. To recap everything, MTU defines the maximum packet size a device can handle without fragmentation. Jumbo frames allow larger packet sizes, usually up to 9000 bytes, for better performance in a specific environment. On FortiGate, you can enable jumbo frames via CLI only by overriding the MTU setting. You should understand your application architecture before performing these MTU changes and your downstream or upstream devices if you have a high traffic flow in the organization. And at the last, if you found this video helpful, don't forget to like, share and subscribe for more networking and Fortinet tutorials. Thanks for watching. See you in the next video. Thank you so much.